Hi friends, in the continuation of data science interview question answer series, we are moving to question difference between data scientist and machine learning engineer. Primary focus data scientist research, analysis and modeling to extract insight and predict outcome. Machine learning engineer building and deploying production ready ML system and infrastructure. Key questions. Data scientist, what insight can be derived from the data? What is the best model? Machine learning engineer, how to scale the model, how to ensure reliability and low latency. Core skill, data scientist, statistics, domain knowledge, hypothesis testing, data visualization, communication, ML algorithms. Machine learning engineer, software engineering, ML ops, distributed system, model deployment, API deployment, cloud computing. Typical deliverables: data scientist Jupyter notebook with validated model prototype, report, and visualization. Machine learning engineer, production API endpoint, Docker container, automated training pipeline, CI/CD. Programming focus: data scientist, primary Python, R for exploration and statistical library, Pandas, scikit-learn. Machine learning engineer, primarily Python, Java, Scala for production code and engineering framework, Spark, Kubernetes, Airflow. ML depth, data scientist, focus on broader range of models and quick experimentation. Machine learning engineer requires a deep understanding of model optimization, performance, and deployment. Example, model serving framework, role in life cycle, model prototyping, data scientist, model prototyping, research and development phase, machine learning engineer, ML ops and deployment, production and maintenance phase, career trajectory. Data scientist often lead to analytics manager or chief data officer. Machine learning engineer often lead to ML ops engineer or staff software engineer. Moving to difference between A/B testing or multivariate testing. Number of variable. A/B testing compare two versions of single variable or a fully distinct page feature. Multivariate testing compare multiple variables elements simultaneously. Hypothesis type. A/B testing global hypothesis, which entire version A or B perform better. Multivariate testing interaction hypothesis, how do different element, example headline and bottom color interact. Number of variants and A/B testing, typically A1, 2 to 4 distinct versions. Multivariate testing, a high number of combination, example 3 headlines, 4 images, 2 buttons, color equal to 24 total versions. Traffic sample size. A/B testing require less traffic and less time to reach statistical significance. Multivariate testing requires significantly more traffic and longer run time due to large number of combinations. Focus of insight. A/B testing simpler to set up, monitor and analyze result. Multivariate testing more complex to design, execute, and interpret the interaction effect. Use case in ML, A/B testing comparing two distinct model version, model A versus model B in the production. Multivariate testing, optimizing multiple feature input or hyperparameters simultaneously in live production environment. Risk. A/B testing lower risk of inclusive result due to the limited number of comparison. Multivariate testing, higher risk of inconclusive result or false positive due to testing noise across many variant. Difference between clustering and classification. Clustering is unsupervised learning, classification is supervised learning. Clustering requires unlabeled data input only feature. So classification requires labeled data input feature and a target class. clustering to discover natural grouping of latent patterns within the data, classification to predict the predefined class label for new data points, clustering cluster ID, customer segment 1 to 3, classification, a class label cat, dog, spam, not spam. Clustering algorithms are based on similarity distance, example, Euclidean distance to a centroid. Classification algorithms are based on learning a decision boundaries, example, hyperplane split rules. Clustering intrinsic metrics like silhouette, score, coherence, and separation or elbow method. Classification string metrics like accuracy, precision, recall, F1 score requires known true labels. Clustering, customer segmentation is marketing, identifying groups of similar products. Classification, fraud detection, fraudulent, legitimate image object recognition. Clustering, k-means clustering, hierarchical clustering, DB scan, Gaussian mixture model, GMM. Classification, logistic regression, SVM, decision tree, random forest, and CNN. Please like, subscribe, and share the channel. Thank you.